So if you imagine this situation in real life, you want your resultant velocity to be perpendicular to the bank. So if the river's flowing, as it is, to the right, you'd have to aim to the left, so that when that current takes effect, your resultant velocity ended up perpendicular. So we can get this triangle. Aiming in this direction, the river bringing you back here to leave you with your resultant velocity there. So neatening that up a bit, you can see we've got that triangle. And the first part of the question is asking us to find that the angle alpha is to show that it's 66.4. So you'll see that that angle is actually the Z angle there. So alpha is the same as this top angle in my triangle. So we can use our trig from GCSE to find that angle. So to find this angle here, we've done inverse cos of adjacent over hypotenuse. Get that answer out to three significant figures, that's 66.4, and because of our alternate angle here, that angle there would be the same as that, which is alpha marked on the diagram. Right, the next thing it's asking us to do is find the magnitude, the resultant velocity of the boat, so that is the third side of my right angle triangle, so you're simply going to use Pythagoras. So because one of the sides we're looking for is one of the shorter sides, then we've taken away, so we've done 2 squared minus 0.8 squared, square rooted it and got 1.83 metres per second. Right, the next part tells us that the width of the river is 14 metres. Find the time that it takes for the boat to cross the river. Well, because we're dealing with the width, that's the perpendicular distance between the banks. So it's that component of the velocity that I'm going to use. So using the resultant velocity, which is perpendicular to the bank, using the perpendicular distance, which is 14 metres, I can then simply use v equals s over t to find t. Because in these questions we're dealing with constant velocities, there's no acceleration. So I've rearranged that to get t equals s over v, subbing in s and v, you get 7.64 seconds. If you can keep the value you got for the resultant velocity in your calculator, so even though I'm writing 1.83 down and actually substituting in the unrounded version, then you're going to get a more accurate answer. And as always with mechanics, unless told otherwise, you're going to round to three significant figures.